I'm back. Let's get this thing started. It's great to be back. Another week. It's already Wednesday. Where's the time going? Let's quickly see if everything works. I should be live on LinkedIn and on YouTube. And then we're going to start. Let me quickly check. Do me a favor, if you can see me, say a quick hello in the chat, and if this works. Okay, I think I can see people coming in on LinkedIn. All right, great. So, what are we going to talk about today? We are going to talk about today data engineering roadmap for data scientists. I've been thinking about, what could we do from roadmap side? Because people are always interested in how can I get into data engineering? How can I start this? I need a roadmap, step by step, what to do. And I already did this with the data analyst side, a roadmap. Let's do one for data scientists. So how this works, let me show my screen. How this works is I went in and I listed down all the courses that I have in my academy. Because I always say the academy is modular, fits to all the jobs, and there are different starting points and different things to do. So I listed down everything, and then I thought to myself, how could I organize this that makes sense for a data scientist? A data scientist usually starts with the data science part, right? You know how machine learning works, you know how to pre-process data for your algorithms to work, and you maybe know a bit how to deploy them on your computer or maybe a bit in the cloud, but that's usually something where people are unsure about. As a proof of concept, this might be your thing that you can do that, but how do you actually set this up as a platform, as a pipeline from beginning to end, right? From data integration or getting the data to actually then putting the data into a destination so people can work with it. All right, so hello everybody. We are going to start. Let me quickly check. I see a few people on YouTube. There are a few people here on LinkedIn as well. How does LinkedIn go? Okay, because I don't see a chat. Say hi in the chat so I know that it works. And then we're going to start with this. Do me a favor. Come on. It's just a quick message. Just so that I know the audio is good and that I'm not talking and the image is bad. Okay. All right. I can see people. So it seems like rock and roll, yeah. Marcus. Oh, okay. So there are nobody says the audio is terrible. Then let's start. Okay. So my idea was with this. Again, I said, machine learning, right? So what is it that the scientist needs to do? Needs to build pipelines, needs to most likely build a platform end to end, especially in smaller companies where there are no engineers or there's a small team. You want to build a good proof of concept and then go from there. So you need to somehow, the end goal is to understand platforms, know how to develop on platforms, and know how to deploy your code. Right? So I was thinking, where do people start? A good thing to start is something, a course that actually helps them, sets the basics for platform and pipeline design. How does the platform look? What are the individual parts of the platform that you always have? What are the different storages or storage categories and so on? What's the streaming pipeline? What's a batch pipeline? That kind of stuff, right? Then I added this here. This is basically optional. Platform security is also good to know for the scientist. Hopefully there is somebody in your company that also can help you with that. But I think that should be here as an optional. That's why I have a dashed line here. Then, okay, what do you usually have? You need to choose data stores, right? The data is coming in. The data will be, you will get the data from a database or some kind of store, and then you need to store it in a way that people can access it in a very fast way and in an organized way, right? And you need to understand, okay, there are relational databases, there are data warehouses, there are NoSQL databases, or like the big data databases like key value stores, document stores, and so on. So you should understand, okay, what are these and why am I going to use them in certain use cases? On that, I also put in here data modeling 1, which is the adjacent or the complementary part to this. How can you, let's say you have a key value store, how can you build a schema for this store? How can you then put your data in it? Or if you have a document store, because let's be honest, document stores, very often you have configuration files in your machine learning and the configuration for your algorithms and so on. So it makes sense to put them also in a document store, right? To manage your actual algorithms, to manage your processes. So this is where you can understand, okay, how can I design something for relational, for a non-relational database, and so on. On top of that, optional here, we have data modeling 2, relational data modeling. I think that makes sense for many data scientists because, like, let's be honest, it's good to understand how to set up a quick relational database like a MySQL database or a MS SQL database and put some data into that that you need for management, right? Or even for a simple client. So I think that is something important. Also, from when you think about the getting the data in, sometimes you have to access data from a database, and this a relational data modeling course, this helps the scientists who are not that firm in that topic to understand the databases, where the data is coming from, to understand the model of the database and how the tables fit together and so on. So I think that is a good foundation. Green are the fundamental parts, our platform and pipeline design fundamentals. With that, I think that's a well-rounded of design part. So before we go further here, let's go. There's a question. Sort of the question: do you plan to produce the same content about roadmap for data engineering for data analysts? I already did. I already have the last live stream or the live stream two times ago. Last week we did a live stream on this. Also, if I have linked on YouTube, I have linked the cookbook, and in the cookbook I have a roadmap for data analysts, and with the whole roadmap you can download that image, and also with the text that we created from that live stream. Yeah, here's the link to the live stream, so you can also watch that. Also, that roadmap that we are talking right now, that is also in my cookbook. So again, that's linked. We have the cookbook, a table of contents, in a larger and a real detailed. I need to fix something here, but here's the roadmap for data scientists, and then you can just click on it. So you find that in the YouTube description, and it should also be on LinkedIn in the description. So now the basics are done, right? People understand what's going on. And now you need to, as a scientist, you create code, you create you train your algorithms, you want to deploy this somehow, right? And I think a fundamental part here is Docker, that you need to understand how Docker works, how you can package your algorithm into a Docker container, or actually an image that runs then as a container, for instance, in the cloud or anywhere where there's a Docker container deployment system, like Kubernetes or the systems on the cloud. So I think that is something you need to start first, very quickly, because that will allow you to do a lot of cool things. Many people already have that skill, but I think it's good to start again and go over this. So I think that is, if you haven't done this, then you should go and should do Docker fundamentals. Then there are multiple ways how you can go here. We have the course also, if you want to get a brush up a bit on data preparation and cleaning for machine learning. We have the course from Andrew from Data Science Infinity in the Academy, where you can also brush up on these skills. That's something you could go after that, or you say, okay, I'm going towards deploying this, going towards building whole pipelines. Right? And for that, I think there are a few things. I would go first the upper way here. I would go into API fundamentals, that you understand how do APIs work, how can you build APIs, how can you access APIs, because right, your Docker code or your algorithm, most likely you want to make this accessible as an API, right? So that it's super easy for everybody within the company to access this. Just deploy it as a container, and that container gives or opens up an API, and this API can then queried or used by other programs or other people. Right? So API fundamentals, then I would look into Apache Kafka, because streaming is an important part of this whole thing, right? You train your data in a batch manner. You get all the data, you train it, and then you have an algorithm. But then when you apply it, usually or very often, it makes sense to actually do this in a streaming manner. So it's important to understand Kafka. And from this point on, with the stuff that I have in the Academy, you could go two ways. You could go the AWS way here, or you could go the direction of, okay, let's go into document streaming. Let's build a full pipeline with MongoDB, with Apache Spark to pre-process the data and then put it into MongoDB, and then have build a user interface in the browser through Streamlit, where people can actually then visualize this. So that's one way I think is very helpful. Understand APIs, understand how message queues work, because you can use them a lot, and then understand or work with the document store and Spark as a bonus, and then build a user interface. So before we continue, how's the roadmap for data scientists different than the others who are transitioning to data engineering? It's completely different, right? So I don't want to go into details. Like here's one for software engineers. The middle part here, platform security, choosing data source, that's the same. But here they start usually with Python for data engineers, then data preparation and cleaning, and so on. Or for analysts most likely want to start with a data warehouse, and dbt for processing data in data warehouse. And so it's different because people have different jobs, have different starting points, right? That's the idea. And so this is the starting point for the scientists, and how the scientists can then go further. Right? So let's say, okay, you're here, you have Spark. Now you want to work with a cloud platform. It makes sense. I have something for data engineering on Databricks, a large course where you can get hands-on on Databricks and learn how to use Databricks. So this is also a part that you could say, okay, I'm not doing the complete document streaming project, but let's do something on Databricks now that I have the Spark fundamentals, right? Or you could say, okay, I'm going here, APIs in Kafka, and then I'm moving more towards the AWS route here. And we have stuff on GCP, we have stuff on like we have here data engineering on GCP, we have data engineering on Azure, which is a streaming pipeline that we built. GCP is also like a stream and a batch part, but this is just an example with AWS here, where you say, okay, now I'm building stream and batch pipeline in AWS, learn how to use AWS, because I need to use a streaming pipeline there with Kinesis and build APIs. And then once I understand AWS, once I understand how to use it, you go towards machine learning and containerization on AWS, right? You have your Docker knowledge, you know how to build an image, how to productionalize your code. Let's use an image registry, let's use the cloud to actually deploy this as a container or as a serverless function on AWS. That's something that absolutely makes sense for a scientist. If I use Conda, will it be okay? Yeah, okay. I think for most stuff we use Conda in here, so it's not super. This is not super complicated. Do I recommend Google Data Engineering certification? I haven't looked into that much. If you want to work on Google, if Google is the thing, it makes sense to do this. So it makes sense to do that certification at some point. Maybe not in the beginning, but certifications are good to show people that you understand the basics, that you know how to work with a platform. Also, some jobs require you to have a certification, so it can help. Where can I find these roadmaps? Asks maybe you're on YouTube. In the description of this live stream, I have I put the link to the cookbook, to my free data engineering cookbook. You can just go there, and this leads to GitHub, and there's everything, and also these kind of roadmaps. Okay, so this much for building pipelines, right? Building pipelines on the cloud or in a Dockerized environment, using fundamental tools that you might want to use. You could say, okay, AWS, we could bring in here a bit of GCP as well, right? We could say here, data engineering on GCP, we bring this here actually as an alternative to this. Let me make this right like this. The thing is, now that you have this, what's the problem that you very often have? A problem that scientists very often have is they want to monitor their algorithms, they want to monitor the data, they need to figure out, okay, what's actually happening right now, which is the toughest part. Understanding what's happening right now and figuring out if there's a problem or not is a big deal. So you need some kind of way of monitoring. Oh, and of course, scheduling or organizing, orchestration. Airflow makes sense to look into Airflow. Once you have your code, you have a Dockerized environment. Let's work on scheduling the pipelines, right? Or orchestrating the pipelines. Then it makes sense to where I was trying to get to, something where you can say, okay, I'm writing logs, I'm writing statistics, and I'm taking these from my environment or from my machine learning algorithms that are running. They are writing metrics into stuff like, for instance, Elasticsearch, where you can analyze logs, where you could put in your metrics, and this way you have an interface where you can search, you can run analytics, you can create dashboards on top of it, and figure out, is everything working, right? You could also put in some statistics about the data that is coming in there. Data observability is something that a lot of people talk about, right? That's something makes sense to look into Elasticsearch. Or you say, okay, I want to do this actually. I have a lot of time series data. I have a lot of detailed statistics or detailed information, time-based information from my algorithms. I built something with InfluxDB, with Grafana, and basically a time series database with a dashboard where I can then look at the data and see the metrics and understand what's going on. Right. So the basics of platform and pipeline design, understanding how to deploy your stuff. Then this part here is more about working in the cloud, working on data platforms, how to build these pipelines with examples. And then below here, that is orchestration and actually working with the metrics, working with statistics, analyzing the logs of your applications. I think that is how I would start as a scientist and get into the engineering part. This would basically allow you to set up a platform from beginning to finish, so that people can actually then analyze the data. The data engineering on AWS part that also has a data warehousing part in it. Makes sense to do this. Or you say, we could actually modify this a bit. We could actually say here that we do this. Now that I'm talking about it, we could actually say we're doing something like this, and then we're bringing in here the modern data warehouses and data lakes part, because that also has that has a GCP and a AWS part. And this allows you to understand, okay, how does BigQuery work? How does Redshift work? How can you use the data lake to access the data, query the data, work with the data, and give this data to analysts and basically enable analysts to process the data or work with the data. That's also, I think I'm going to change this. I'm going to redeploy the GitHub after the stream. Yeah. All right. That was the core content that I wanted to bring today. Let me know more questions in the chat. I can answer a lot more. I have a bit more time. I think it's an important part for the scientists to understand engineering, to be able to do a bit of engineering. Very often in smaller companies, in the beginning, it's good if you're hands-on and if you be able to do as much as possible. Either way, I have a lot of people in the academy that are scientists and that use this. About the academy, let me bring up the academy, because I was haven't talked about this yet. So if you go to learndataengineering.com, this is where my academy is. As I said here, for beginners, professionals, for data engineers who wants to learn more, and also for scientists. And here's my academy. I helped over 1,500 students. We're very close to 2,000 actually, and with many tools and many courses. These are all the courses that I have in this overview here that you have on GitHub. Where is it? Here, the overview of this is actually all the courses that you can find here. Over 50 hours of video material plus source code for everything. You can do a lot in 1 month, in 3 months, and so on. This is how usually the courses look, with me explaining stuff with our Discord server that we have. So take a look at learndataengineering.com and the academy. That can help you, and everything that I just shown I have in the academy, so it's really helpful. Okay, I don't see a lot of more more questions here. Any insight into any insight into data engineering as it pertains to building automation or any field where data management is not core to the business? Is data extraction usually the hardest part of the project? No, not really. The hardest part is usually working with dirty data and understanding the goals, and basically then trying to get the data into a form where like the analyst then can work with it, right? Building the whole platform step by step. There are so many things, like the management of the pipelines, the bug fixing, and so on. So data integration, or getting the data, that is just one part of the whole thing. The core, very often the core problem is actual communication. That is one of the things where people struggle a lot, where the business is not describing well what is actually required or what their goal is with this, where the business is not talking to the engineers are not asking the right questions to the business. Sometimes there's animosity between these people, right? So very often, actually, communication is the hard part, because we engineers discuss stuff differently than business people. So yeah, I did a course on LinkedIn Learning that you can access about problem solving for data engineers, and a lot of this is actually communication based, I think. Should I know about data science if I'm looking to learn data engineering? I have the basics in there so that you understand basically what a data scientist needs, what's the goal of actually the data science part and machine learning. You don't need to know how to actually do it. Also, with Andrew's course that I've shown with this data preparation and cleaning for machine learning, that is something that also can give you a bit of insight into the stuff for, or what data scientists need. But it's not like that you need to be really good at, or you need to do this. You need to understand the basics. I'm not a scientist. I can't do any data science. I can't do any machine learning. I have zero skills there, but I understand what it is. I understand the requirements, the needs, and I know how to communicate with these people and try to help them solve their problems through engineering. Yeah. Right. We're half an hour in. I want to keep this short. I want to come here more often, but keep this short. So if you have more questions, let me know either in the comments here on YouTube. Go to this video on YouTube in the comments, or you can also reach me on Twitter. Just add me on Twitter. I'll look into Twitter, or you can also get in touch with me through Learn Data Engineering, because I think here, if you go to the main page on the bottom, we have a contact email, or I think also when you're in the academy, on the bottom is always the contact, how to get in touch. So you can send an email. Yeah, this goes to our email. So let me know. And thanks for being here. I hope this was helpful. Again, you can find this in the cookbook. Use the link. It's absolutely free. You don't need to log in or join the email list. It's a free cookbook, and I'm working on this right now. I'm adding more stuff. I actually started this 2020 or something, or 19, but yeah, it's actually a lot of fun. Yeah. So see you later.